A creature sits motionless in the corner. It weighs less than a paperclip. It's 50,000 times smaller than you. Yet when you see it, your heart rate can spike by 40 beats per minute. Your palms sweat, and sometimes you scream. Not a logical response, not a proportional response, but a programmed one. I'm your host, and this is Anatomy of Fear. Today, we're untangling one of humanity's most common yet least understood phobias, arachnophobia, the intense, often irrational fear of spiders and other arachnids. Here's what makes spider fear so fascinating to scientists. It's disproportionate to actual threat. In most parts of the world, the spiders you encounter are harmless, yet your brain reacts as if you've encountered a predator. This isn't random. It's not cultural conditioning alone. It's evolutionary programming, so efficient that your visual system detects spider-like shapes 0.25 seconds faster than other potential threats. In the next 18 minutes, we'll explore three critical layers. First, the evolutionary wiring that makes spiders stand out in your visual field. Second, why this fear persists despite minimal actual danger. And third, how cutting-edge 2026 therapy is using augmented reality to literally recalibrate this ancient alarm system. Let me introduce you to Alex, a software engineer in Seattle. Alex can debug complex code, manage teams, give presentations to hundreds. But show Alex a photo of a common house spider, and physiological monitoring shows immediate changes. Pupil dilation increases by 30%, skin conductance spikes, and heart rate jumps from 72 to over 110 beats per minute. The paradox? Alex knows intellectually that house spiders in the Pacific Northwest are essentially harmless. None are medically significant. Yet this knowledge doesn't reach the fear response. Alex represents approximately 3 to 6% of the global population with clinical arachnophobia, but up to 50% experience some level of spider aversion or discomfort. A 2024 study from Uppsala University tracked eye movements and found something remarkable. When shown rapid-fire images of various objects, participants consistently detected spider images faster than images of needles, snakes, or even guns. The detection advantage averaged 0.25 seconds, a quarter-second head start that your brain gives to spider-shaped objects. Now let's examine the neuroscience. Why does this happen? Modern neuroimaging reveals that spider fear activates a specific, prioritized pathway in your brain. Unlike generalized anxiety, which involves diffuse networks, arachnophobia lights up a relatively direct route from visual cortex to amygdala. When your visual system detects certain patterns, multiple legs arranged radially, quick jerky movements, certain size-to-leg ratios, it doesn't send this information through the standard processing pipeline. Instead, it takes an express route. This express route involves the pulvinar nucleus of the thalamus, which acts as a bypass, sending visual information about potential threats directly to the amygdala before the conscious analytical parts of your brain have fully processed what you're seeing. The result? You feel fear before you fully understand why. Your body reacts before your mind catches up. This system evolved because in our ancestral environment, quick spider detection could prevent bites from medically significant species. But in modern environments, this same system fires at harmless house spiders, creating false alarms. Layer 1. Evolutionary preparedness theory. Proposed by psychologist Martin Seligman in the 1970s and validated by modern neuroscience, this theory suggests humans are evolutionarily prepared to fear certain stimuli that posed threats throughout our evolutionary history. Spiders are a prime example. Unlike fear of cars or electricity, modern dangers, Spider fear requires minimal conditioning to develop and is difficult to extinguish. A 2025 meta-analysis published in Evolution and Human Behavior examined 47 studies across 15 countries. The finding? While cultural factors influence the intensity of spider fear, the baseline preparedness is universal. Infants as young as 6 months show heightened attention to spider-like shapes compared to other insects. This suggests the template is innate, not learned. Your brain comes with a pre-installed spider detection template that gets calibrated by experience. Layer 2, the visual signature advantage. What exactly makes spiders visually distinctive? Research from MIT's Department of Brain and Cognitive Sciences identified 3 key visual features that trigger rapid detection: radial symmetry, legs extending from the central body, high contrast between body and environment, and specific movement patterns, quick, unpredictable jerks. Your visual system has dedicated neurons that respond preferentially to these patterns, much like face recognition neurons. This creates what's called a pop-out effect in visual search tasks. In arrays of distracting objects, spider images literally pop out visually, requiring less cognitive effort to detect. This isn't true for most other feared objects. Needles, for example, require systematic search. Spiders capture attention automatically. Layer 3, cultural amplification and the feedback loop. While the detection template is innate, culture amplifies or moderates the fear response. Consider 2 examples. In regions where spiders are part of traditional medicine or folklore, like some indigenous cultures in South America, spider fear is significantly lower. In contrast, in Western cultures, where media consistently portrays spiders as dangerous or sinister, the fear response is amplified. This creates a feedback loop. Innate detection template plus cultural narratives equals amplified fear response. Movies, stories, and even children's books that portray spiders as villains reinforce the evolutionary template. Your amygdala doesn't distinguish between real spider and movie spider at the initial detection stage. Both activate the threat detection system, which then gets reinforced by the emotional content of the media. But here's an important nuance. This cultural amplification works both ways. Recent therapeutic approaches actually use positive cultural narratives to reduce fear. By exposing individuals to cultures where spiders are respected or even revered, and by sharing accurate information about spiders' ecology, therapists can begin to rewrite the cultural narrative component of the fear. Now, the solutions. Understanding the mechanism is essential, but transformation requires practical strategies. Here are 3 evidence-based approaches, including one that's revolutionizing treatment in 2026. Solution 1. Augmented reality gradual exposure therapy. Traditional exposure therapy for arachnophobia might involve looking at pictures, then being in a room with a spider in a container, then gradually closer contact. The 2026 approach uses augmented reality, or AR, to create controlled, customizable exposure scenarios. You wear AR glasses that superimpose virtual spiders onto your real environment. The therapist controls every parameter: size, movement speed, distance, even the number of legs. The breakthrough? Biofeedback integration. The AR system monitors your physiological responses in real time, heart rate, breathing, skin conductance, and adjusts the exposure accordingly. If your anxiety spikes too high, the virtual spider moves farther away or becomes translucent. As you calm, it moves closer. This creates what's called a perfect exposure curve, always challenging but never overwhelming. Early clinical trials show 68% reduction in fear responses after just 8 sessions. Solution 2. Cognitive ecological reframing. This approach addresses the narrative component of spider fear. Instead of trying to eliminate fear entirely, it seeks to transform fear into respect through education. You learn about spider ecology, how they control pest populations, their role in ecosystems, their fascinating behaviors. You learn to identify common house spiders and understand that most are harmless. The key shift is from spiders are dangerous to some spiders can be dangerous, but most are beneficial and want to avoid me as much as I want to avoid them. This reframing changes the emotional valence from pure threat to nuanced understanding. It doesn't necessarily make you love spiders, but it can transform paralyzing fear into manageable caution. Solution 3. The Safe Spider Protocol Development. Based on 2025 research from Johns Hopkins, this protocol involves creating a personalized safe spider template in your brain. Through guided visualization and controlled exposure, you learn to distinguish between medically significant spiders, extremely rare in most areas, and harmless ones. You develop what researchers call discriminatory fear, fear that's proportional to actual risk rather than blanket terror. Now, let's bring this full circle. Arachnophobia isn't a personal failing or weakness. It's an evolutionary success story operating in the wrong context. Your brain isn't broken, it's overperforming. It's a threat detection system so efficient that it sometimes activates when it's not needed, like a smoke detector that goes off when you toast bread. When you feel that visceral reaction to a spider, recognize what's actually happening. You're witnessing millions of years of evolutionary refinement. You're experiencing a detection system that kept your ancestors safe from medically significant spider bites. This system, while sometimes inconvenient in modern life, represents an incredible biological achievement. But here's your advantage. You have knowledge your ancestors didn't have. You have statistics. Most spiders are harmless. You have tools, AR therapy, cognitive reframing, ecological education. You have choice. So when that ancient alarm sounds, you now have a new response available. Thank you for trying to protect me. I appreciate the warning, but I have new information. The data says this particular spider isn't a threat, and I choose to respond with curiosity rather than panic. Because true courage isn't absence of fear. It's the informed decision to act differently, despite understanding exactly why your evolutionary programming is sounding the alarm. It's choosing present knowledge over ancestral programming. If today's exploration has helped you understand that your spider fear is actually an evolutionary success story needing calibration, then prepare for our next descent into the architecture of fear. We're about to shift from eight-legged creatures to the psychology of enclosed spaces. When does a room become a prison in your mind? Why do MRI machines trigger panic attacks when they're statistically safer than your daily commute? Claustrophobia awaits us, and its neural mechanisms reveal fascinating truths about how your brain calculates space and escape probability. Subscribe to Anatomy of Fear and hit the notification bell. The next exploration changes our environment, but not our depth of understanding. For now, remember this. Every time a spider triggers that ancient alarm, you're witnessing your own incredible evolutionary inheritance in action. Today, you've learned not just to fear the response, but to understand its origin and to choose your reaction.